Hello students, I welcome you to Eduno classes. I am Shubha Patel to take up your mathematical reasoning classes. Students, today we will study about boats and stream. It is basically based on linear equation in two variables, and we will understand the concept and solve a few problems on it. So students, in these kind of questions we have a boat and a stream. So now there can be two cases. If the stream is this way, then the boat can be in direction of the stream, or that is downstream. When the boat is in direction of is in the same direction as the stream, it is called downstream. Second is, stream is this way and the direction of boat is this. So this is called upstream. When it is upstream, when the direction of the boat is opposite to that of the stream. Now if you are watching it from here, if suppose this is the observer, then you have two kinds of velocity. Okay, there are two kinds of velocity for this observer, right? First is the velocity of the stream and second is the velocity of the boat. Now if there was no stream, if the water was still like this, then the boat would have a velocity called S, velocity of boat in still water. What is S? Velocity of boat in still water. What is still water? When the water is not flowing with any speed, it is still, stagnant, right? This velocity and the other velocity will be of the stream. So we also represent stream velocity by C, that means current, the velocity of the current. So this means that if a person is rowing the boat in the direction same as that of the stream or current, it will be pushed automatically by velocity of the current and by its velocity with which it is already moving. It will have two velocity. One velocity will be of that velocity by which it rows on still water, velocity of boat in still water, and it will also have velocity of the stream. Fine. So suppose you are on top of a bus, it's a long bus, this bus is moving with a certain velocity, and also you are running on the top of the bus with certain velocity. Now you have two velocities, right? You also have the velocity of the bus and velocity of yourself, because you are running on a ground, right? You are running on a ground. Suppose the ground is also moving with certain speed. Now you have the speed of the ground as well as your speed, right? Similarly, if this boat also has two velocities. One velocity is velocity of the boat in still water, and the other one will be velocity of the current. If it is downstream, what if it is upstream, that is it is going in the opposite direction, then it will have again two velocities but in opposite direction. So it is S minus C, that is velocity of the boat in still water minus velocity of the current. Why? Take this example. Suppose you are running in this direction, but the ground is moving in this direction. So your speed will be, suppose you are running on this on this ground which is at rest. You are running with something like 1 kilometer per hour, whatever is your speed. Okay, what if this ground starts moving in opposite direction with any speed, suppose 0.2 kilometer per hour, will your speed increase for observer who is observing from here? Will he or she see you as running faster than 1 kilometer per hour or slower than 1 kilometer per hour? Slower than 1 kilometer per hour, because you are also trying to overcome this speed of 0.2 kilometer per hour in opposite direction. So now your speed is 0.8 kmph. 1 minus 0.2. Fine. So in downstream you have two velocities adding up. Velocity of the boat in stable water, that is velocity of boat in still water, which is represented by S, and velocity of the current. Both are in same direction, so it will add up. Your speed will be more, your actual speed of moving on the water will be more than your speed in still water. Why? Because the water is also pushing you forward. But if you are going upstream, opposite to the direction of flow, then you have to overcome the flow and you have your speed as well. So your real speed, actual speed by which you are flowing on the water will decrease, because you are also trying to overcome the current velocity of the stream, which is in opposite direction. Fine. So remember this, for downstream we have both the velocities added up, and in upstream we have both the velocities getting subtracted.